Good morning, students. Today we will start the chapter of real number of standard 10. This is the first chapter that you have to learn. The real number, the word is not a new thing for you. In your earlier classes also you have come across this word real number, rational number, irrational number, natural number, whole number, integers, fractions, so on and so on. Now the thing is, here in standard 10, the same thing you have to learn once again. That means we have to recap whatever you have learned in your earlier classes, in your junior classes, along with two different things in the chapter of real number. These two new things that we will come across is, one is Euclid's division lemma, and the second one is the fundamental theorem of arithmetic. Now, before going into lemma and fundamental theorem of arithmetic, we will just recap whatever we have learned in our earlier classes. That is the real number. Now, we will see the number system. In number system, all the numbers are there. Whatever number you can think, that number is there in the number system. This number system is classified into two categories, two broad categories. One is real number, and the second one is imaginary number or unreal number. Now the very first outset, at the very outset, we have to understand what the real number is and how it is different from imaginary number. Simply, whatever number you are thinking right now, what I mean to say, up to standard 9, whatever number you have come across, all those are real number. The definition of real number goes like this: a number whose square is non-negative is called a real number. A number whose square is non-negative is called a real number. An imaginary number, a number whose square is negative. Remember, we have to learn real number in details. So, a number whose square is non-negative is called a real number. In your book, you will find the definition goes like this: combination of all rational and irrational numbers. Irrational numbers are called real number. So two definitions we are finding. One is a number whose square is non-negative is called a real number. The second one is combination of all rational and irrational numbers is called real number. So what is the thing? This is known as the composition definition of the real number. What real number is made up of? Real number is made up of rational number and irrational number. And this is the definition of real number, a number whose square is non-negative. So real number can again be classified as rational number and irrational number. Dear students, you have learned all these things in your earlier classes. Once again, we are recapitulating the thing that you have learned previously. Nothing more. So the square, now here the thing is a number whose square is non-negative. Take any number, imagine any number that is coming to your mind, say 5, root 3, minus 6 by 7. 3 numbers we are taking. We have to verify, we have to check whether the given numbers are real or not. What we will do? Well, we will just take the square of that number. That means if we want to check whether 5 is real or not, we will do the 5 square. That will give us 25. And obviously 25 is greater than 0. That means 25 is positive. Therefore, 5 is a real number. Root 3 we have to check. Well, we will write root 3. It's a square. It will give us 3. Again, it is positive. So root 3 is again a real number. Minus 6 by 7 we have to check. We will put minus 6 upon 7 whole square. We will get 36 by 49, and that is positive. Hence, minus 6 by 7 is also a real number. Thus, a number whose square is non-negative is called a real number. Here what we are finding? We are finding all the numbers square is positive. On the other hand, you take 0. Whether 0 is a real number or not, in order to check it, we will do 0 square, that is 0 itself. So, due to the existence of this single element 0, this word non-negative is used. Otherwise, we could have defined it as a number whose square is positive is called a real number, but we are not doing so. We are simply saying a number whose square is non-negative is called a real number. Non-negative, the word came due to the existence of the single element 0. Because 0's square is not positive. 0's square is 0, and it is, therefore, we have used the word non-negative. So, I have explained all these things. Hope you have understood. Now, think one point, come to one point. Just give me an example of a number whose square is negative. Say, in order to find such a number, what you will do, you will put the square root sign. And within that square root sign, you put a minus sign and put any value you can put. So root over minus 5. We have to check whether the number under root minus 5 is real or not. What we do? We will take the square root of minus 5. What we will get? Minus 5. What it is? Negative. So the square of under root minus 5 is negative. Therefore, under root minus 5 is unreal number or imaginary number. This imaginary number and unreal number we have to learn in details from standard 11 onwards. Right now we have to focus our attention to the real number only. So we see that real number is classified as rational number and irrational number. You better know, you must remember that any number which can be represented in the form of p by q, where both p and q are integers, is called a real or rational number. And I told that a number which cannot be represented in the form of p by q, where p and q both are integers and q not equal to 0. So what we are doing, we are saying can be represented, and here we say which cannot be represented in the form of p by q. Rest things are equal, where p and q are integers and q not equal to 0 is called rational number. Again, this rational number is classified as natural number, whole number, integers, fraction. Natural number, whole number, integers and fraction. So remember again, once again, a number which is in the form of p by q, number in the form of p by q, where both p and q are integers and q not equal to 0 is called a rational number. A number in the form of p by q where both p and q are integers and q not equal to 0 is called a rational. Remember, each and every word that I have written in this definition is very important. Don't miss a single word in this definition. And if a rational number is asked, a number which is not, only you add the word not. Number not in the form of p by q, where both p and q are integers, a number which is not in the form of p by q, where both p and q are integers and q not equal to 0 is called an irrational number. So suppose now we have to give the examples of the rational number. Examples of rational number. Examples will be 5, minus 27, 3 by 8, minus 15 by 17. All these are the examples of rational number. Now 5 can be written as 5 by 1, where 5 and 1 both are integers and 1 is not equal to 0, therefore 5 is a rational number. Minus 27 can be written as minus 27 by 1. Here the integers are minus 27 and 1 is not equal to 0. So minus 27 is a rational number. 3 by 8. 3 is an integer, 8 is an integer, and the denominator integer, that is 8, is not equal to 0. Therefore it is again a rational number. Minus 15 by 17. Minus 15 is an integer, 17 is an integer, and 17 is not equal to 0. Therefore, minus 15 by 17 is also a rational number. One very interesting property I will explain over here of the rational number, that rational number can be expressed in decimal forms. And when the rational numbers are expressed in decimal forms, they are either terminating or non-terminating, repeating. The decimal presentation of a rational number is either terminating or non-terminating, repeating. And here, okay, let me give the examples of irrational number first. Examples of irrational number. say root 5, root 7, third root of 7, 0.6060060006 dot 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 dot. So the number which is not in the form of p by q, where both p and q are integers and q not equal to 0, is called an irrational number. Root 5, I said irrational number. Why root 5 is irrational number? Because this is the radical and 5 is known as radicand. This radicand cannot be completely taken out from this radical sign. You cannot take 5. 5 is not a perfect square. So 5 cannot be taken out from the radical sign and hence it is irrational. So if a number which cannot be taken out completely from the radical sign, from the square root sign or cube root sign or fourth root sign or nth root sign, then that will be an irrational number. So this is an irrational number. 7 you cannot take out because 7 is not a perfect square. Neither 7 is a perfect cube. So you cannot take out 7 out of this cube root radical, and hence these are the examples of irrational number. The second property, or this is the first difference, this is the second difference. Here we will say the decimal presentation of irrational number will always be non-terminating and non-repeating. See this one, the number that I have written, 0.6060060006 dot 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 dot. What it means? This dot 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 sign means non-terminating. And these numbers are arranged in such a way that you cannot put a recurring mark over any one digit. And that's why it is non-terminating, non-repeating. So any number which is having non-terminating, non-repeating decimals is called irrational number. Here one more important interesting thing is that in example we write pi. Pi is also an irrational number. Remember, very interesting contradiction here is there, that we say that pi is irrational number because the exact decimal presentation of pi is always non-terminating, non-repeating. But for practical use, we take the value of pi equals to 22 by 7. And in this 22 by 7, 22 and 7 both are integers and 7 is not equal to 0. Therefore, 22 by 7 is rational, whereas pi is irrational. The simple reason is the exact value of pi is not equal to 22 by 7. 22 by 7 is a close approximate value of the irrational number pi. Irrational number, actual value of pi is non-terminating, non-repeating. But for practical purpose, we take the value, very close rational value of pi. For the purpose of calculation, we take it as 22 by 7. So both this rational and irrational number, they consist of the real number. So we will see, we have learned also that both rational number and irrational number, which consists of the real number, can be plotted on the number line. Now this rational number are of 4 types. Natural number, all counting numbers are called natural numbers, starting from 1, 2, 3, dot 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 dot. All these are the natural number or counting numbers. Whole numbers are all the natural numbers including 0, 1, 2, 3, dot 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 dot. These are the set of whole numbers. Integers all whole numbers including negative of naturals. That means 0 whole numbers. I am writing 2, 3, 4, dot, 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 and negative of naturals -1, -2, -3, dot, dot, dot. So, dot, 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 -3, -2, -1, 0, 1, 2, 3, 4, dot, dot. So, if it is, these are called positive integers. These are called negative integers. And 0 is neither positive nor negative. 0 is neither positive integer or negative, but it is an integer. It is neither positive nor negative. So, integer consists of three parts. Negative integers, positive. What is integer? All whole numbers including negative of naturals. All whole numbers means 0, 1, 2, 3, 4, dot, 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 dot. Negative of naturals, -1, -2, -3, dot, 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 dot. If it is asked, what is the smallest negative integer? We don't know. If it is asked, what is the largest integer? Largest integer, we don't know. Neither we know the smallest integer, nor we know the largest integer. But if it is asked, what is the smallest positive integer? 1. What is the smallest negative integer? That is -1, like that. Sorry, what is the largest integer? We don't know. What is the smallest integer? We don't know. What are the positive integers? 1, 2, 3, 4, dot, dot, dot. What is the negative integer? -1, -2, -3, dot, dot, dot. If we draw the number line like this, you must remember 0 is here, 1, 2, 3, like it goes like this, -1, -2, -3. That means the values are increasing. As we move rightward, the values are increasing. The largest negative integer is which one? -1. -1 is the largest negative integer. The smallest negative integer, we don't know, up to infinity. The smallest positive integer is 1. The largest positive integer, we don't know. Which integer is neither positive nor negative? It is 0. 0 is neither positive nor negative. Okay. Now the thing is, after discussing this integer, fraction we have to explain, and that will be the just sum total or summary of the first chapter. Fraction. Fraction means if number in the form of a by b, a number in the form of a by b where both a and b are positive integers. A number in the form of a by b where both a and b are positive integer. Now take an example over here. Let me write that 5 by 7. So can we say 5 by 7 a rational number? Undoubtedly, because 5 is an integer, 7 is an integer, and 7 is not equal to 0. Is 5 by 7 is a fraction? Yes, 5 is a positive integer and 7 is also a positive integer. So this is a fraction as well as rational number. But if I write -5 by 7, see, -5 is not a positive integer, but it is an integer. 7 is an integer and 7 is not equal to 0. Therefore, -5 by 7 is a rational number, but -5 by 7 is not a fraction. So what we can say, we can derive, we can see here that all fractions are rational number, but all rational numbers are not fraction. All fractions, all fractions are rational number, but all rational number, this is a fraction as well as it is a rational number. This is a rational number, but it is not a fraction. Students, this is all about the introduction of the real number, And after this, the chapter of Euclid's division lemma comes, and third chapter is the fundamental theorem of arithmetic. As per your NCERT syllabus, I am moving. So in the next session, in the next class, we will discuss the next theorems or the exercises gradually. Till then, goodbye.